Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi guys, how are you? After a long stay at home, now we have a class. Okay, after about 6 weeks 1 month 1 month we have a holiday. Okay, so now we stay at home, but we will study online. So I hope that you all will understand what you will study. Okay, so what you do is, this is our first time class, online class. So what you can do is, you have to become peace and always be happy, as I always uh, ask you to be happy. Alright. Okay, hope you guys are in good health. Okay, so where are we? Before the holiday, we have discussed until uh, G inverse. So we carry on with conditional inverse. Alright. So what is conditional inverse? Conditional inverse of matrix is generally easier to compute than generalized inverse of A. Sometimes it is more desirable to use a conditional inverse rather than G inverse. So the definition, so you can read the definition of C inverse. So we have A. Okay. Okay. So A conditional inverse times A equals to A. So this we have studied before this. Alright. Okay. And then you must know the theorem. We have 3 theorem here. The first theorem is the G inverse. Okay, the G inverse of a matrix A is also a conditional inverse of A, but a conditional inverse of A may not be the G inverse. So do you understand? Okay, we have a theorem. 2, a conditional inverse exists for each matrix, but it may not be unique. And number 3, if A is an m times n matrix, a conditional inverse is n times m matrix. Alright? Okay. Then we have definition for Hermit form. So you must know this definition so that you want to solve the example. After this, we can look for the examples. Alright. Okay. And n times n matrix H is defined to be upper Hermit form if and only if it satisfies the following 4 conditions, where first one, H is upper triangular. So if you want to see whether it's in the form of Hermit, you have to find whether H is upper triangular. So do you know what is upper triangular? Okay, so just now, okay, you want to find what is Hermit. Okay, you can refer to the books. Okay, example, refer to the books how you want to recognize Hermitian matrix page. Okay, this is Hermitian. Okay, you can refer to the book page 438. Okay, refer to this book, new linear algebra. Alright, so here are the theorem. Okay, so a square matrix is said to be unitary if A times A equals to identity, and Hermitian if A star equals to A. Okay, so how to recognize this Hermitian? You can refer to example 2, recognizing Hermitian matrix. Okay, so if you refer to to matrix A, this is Hermitian. Hermitian matrices are easy to recognize because their diagonal entries are real. Why? If you see in the A, okay, this one, see this name. Alright, okay, and the entries, okay. Hermitian matrices are easy to recognize because their diagonal entries are real. Why? And their entries that are symmetrically positioned across the main diagonal are complex conjugates. Thus, for example, we can tell that by inspection that this A is Hermitian. Alright? Okay. So you can refer for these examples. Okay, Hermitian. Okay. Right. Okay. Okay, so let's go to so just now we see H is upper triangle. Okay, definition of Hermit form. Only zeros and ones are on the diagonal. So on the diagonal, only zeros and one. Okay. So if a row has a zero on the diagonal, then every element in that row is 0, right? Okay, if the 0, okay, only zeros. If a 0 has a 1 on the diagonal, then every off diagonal element is 0 on the column in which the 1 appears. Okay, let me see how we want to write this. Okay. Okay. Alright. Let's say we have Hermitian. Let's say this example. This is okay. Let's say I have this matrix 1 0 0 0 0 0. Okay. Sorry for the right. So 0 0 0, and this also 0 0 1. Okay, let's see if a row has H is upper triangular, so this matrix is upper triangular. Only zeros and ones are on the diagonal. If you see here, this is the diagonal. Okay, let me see. Okay, the diagonal is only 0 and 1. Okay, then every element in that row is 0. So every element in that row, is 0. So where is the row? So if you see here, element is 0 0. Alright. If a row has 1 if a row has a 1 on that diagonal, then every of diagonal element is 0 in the column in which the 1 appears. Okay, if a row has 1 on the diagonal. Okay, we see we have 1 on diagonal, then every sorry, I have okay, sorry, we have to do one more time. Okay, 1 0 0 0 0 0 and 0 0 1. Alright, so if we have, okay, so it said here only zeros and ones on the diagonal. So you see the diagonal, this is diagonal, only 0 and 1. Alright, if a row have a 0, let's say we take, okay, if a row has a 0 on the diagonal, okay, here the row, okay, if a row has a 0 on the diagonal, then every element in that row is 0. So if you see here, all the element is 0. Alright, okay, and then if a row has a 1 on the diagonal, okay, let's see. If the row has a 1 on diagonal, so the 1 is here and here. Okay, and then every of diagonal element is 0 in the column in which the 1 appears. Okay, where is the column? Okay, so every column is 0. Okay, you see here is 0 0. So this is this matrix is in the Hermit form. Okay, do you understand? So this is Hermit form. Hermit form. Okay. Alright. Okay. So we continue. Okay. So we have theorem. We have theorem for any n times n matrix A, there exists a non-singular matrix such that BA equals to H and H is in Hermit form. So let A be an n times n matrix. Okay, let A be n times n matrix. Let B a non-singular matrix B such that BA equals to H, where H is Hermit form. Then B is called a conditional inverse of A. Note, B can be written as a product of elementary matrix. Each corresponds to every ERO involved in reducing of A to H. Okay, you have to know this theorem. Alright, let me see the examples. Alright. Okay, let's see this example. Sorry, I have to change the to PDF form because cannot using, there is an error in PowerPoint. So, okay. Oish. Mana ni? Okay. Okay. Okay, I leave it for you to. Then we go to the next. Yes, this is called. So this is called, therefore C inverse of A is, this is called C inverse for A. So this is C inverse for A. Okay. Okay. Okay, then let me see conditional inverse. Okay, what is conditional inverse? We have corollary. Let A be a m times n matrix with m times n, and let A not equals to A where 0 is the m times m minus n column with contains 0. Let B not be a non-singular matrix such that B not A not equals to H where H is in Hermit form. Let B not be partitioned as B not equals to B until B1 where B is n times n matrix, then B is C inverse of A. If m less than n, then A not equals to A per 0, that is at rows of 0 and partition B not as B not where B is n times m. Then B is C inverse of A for this case. Alright, so let's see the examples. Example 2. Okay, so are you still with me? Stay tuned. Hopes you enjoy this class. Okay. Okay, if you feel bored, if you feel sleepy, okay, please be peaceful. How to peaceful? Okay, as I have teach you in the class. So let me start with our breathing. We breath. Let's see, when you breath, do your tummy or your breath go up? Okay. Okay, so do you still with me? We have more examples to go. Okay, for case where m is greater than n, So find C inverse of 3 times 2 matrix where A is equals to 1 to 0. So if you see here, we have the M is 3 and N is 2. So 3 is greater than 2. Alright. So if you see here, 3 times 2. M but A with a column of 0 so that new matrix is a square matrix A naught. Okay. So we have A naught. Reduce this matrix A naught into Hermit form. Okay. Please try to reduce A naught to Hermit form. So do you remember what is Hermit form? Okay, try. You can try now to reduce into Hermit form. Okay. So how to reduce matrix A naught into Hermit form? Okay, what you can do is, okay, how you want to reduce? So H equals to B times A 3 times 2. So H equals to B 3 times 3 and A 3 times 2. So if you see here, we have 3 times 3, so we got B 3 times 2. Alright. Okay, so for this exercise, I let you to try first and I will give you later the answer. So do this exercise, okay, and submit to me before 6 p.m. today. So that is your attendance for this class, for the class today. Hope that you enjoy the class, and I hope that you will understand what I have taught today. And okay, my student, always be happy. So if you like this class, please subscribe to my channel and tick like if you like this. Yeah. Alright. So love you all. See you again. Bye.